Presentation, I will share definition and proof of aberration of light. Aberration of light means the direction of a ray of light appears to be different with respect to different inertial frames of reference having very high relative speed. In order to prove aberration of light, consider two inertial frames of reference S and S dash. Let the position time coordinates of an event be represented as x, y, z, t with respect to frame S and x dash, y dash, z dash, t dash with respect to frame of reference S dash. Suppose initially at t equal to t dash equal to 0, both the frames of reference S and S dash completely coincide with each other, and then frame of reference S dash starts moving in x direction with a constant very high speed v that approaches speed of light. Suppose a ray of light propagates in xy plane and makes an angle theta with x direction with respect to stationary frame of reference S. Velocity of light c vector can be resolved into two components along x and y direction as cx equal to c cos theta and cy equal to c sin theta. Suppose the ray of light makes angle theta dash with x direction with respect to moving frame of reference S dash. In this case, the components of velocity of light in x and y directions can be expressed as cx dash equal to c cos theta dash and cy dash equal to c sin theta dash. According to velocity addition theorem, for x components of velocity of a body, ux is equal to ux dash plus v whole divided by 1 plus v upon c square ux dash. Replace ux with cx and ux dash with cx dash and put the values of cx and cx dash from previous slides. We can obtain a relation for c cos theta. Similarly, according to velocity addition theorem for y components, we can write uy equal to uy dash multiplied with 1 minus v square upon c square under the root whole divided by 1 plus v upon c square ux dash. Replace uy with cy and uy dash with cy dash and put values of cy and cy dash and obtain equation for c sin theta. From previously obtained relations for c sin theta and c cos theta, find ratio of c sin theta to c cos theta and simplify and get result for tan theta equal to sin theta dash multiplied with under root 1 minus v square upon c square whole divided by cos theta dash plus v upon c. This result shows that theta is not equal to theta dash. That is, the ray of light appears to make different angles with x direction with respect to stationary frame of reference S and moving frame S dash. That is, direction of ray of light appears to change with respect to two frames of reference having very high relative speed. Thank you.